everyone at once. What's Hannah saying? That was fun, wasn't it? I'm hoping next semester for the review day at the end of the semester we do like a lock-in / pool party. It'll be rad. Yeah.
Can I come today through 6 to 9?
Yes. I won't stop you.
Can I?
Can we do that all lock-in thing for a quarter exam and the end of?
Maybe, I don't know. I have to ask about the semester thing even. And they'll probably look at me like, what? You're a math teacher. Yes? Yeah, oh yeah, I will. Oh God, yes I will. Until 9. All right, I want to start the review. You guys ready? Here we go, buckle up. I've already shown my work so I can go a little bit faster. Well, please don't. It's half of your final grade. Okay, good. That guarantees you at least a 50% on your final if you do really well on it, okay? So even if you didn't do your final test at all, you'd get a 50 if you did well in your portfolio. You see what I'm saying? So you only need to get a 25 on the final to get a 75%. You can pull it off, okay? If you want, I'm going to be here until 9. You can stay and work on it here or whatever you need, okay? Whatever you need. All right, so for this one, we want to prove that AB, this segment right here, is 15. So here's what I'm going to do. I'm going to find what this segment is and this segment is, because I don't have that information yet, right? I wrote that in. And the way I'm going to do it is I'm going to say, look, BD is negative x plus 1. I'm going to subtract 6 from it. I'm going to get this guy. I'm going to do the same thing with this. AC is x plus 16. I'm going to subtract 6 from it and get this guy. Then I'm going to add them all up and get this guy and solve for x. Plug it back in and get AB is 15. Okay? So here's what I did. It's a lot. BD, the red part, is the green part plus the blue part. So I wrote that by segment addition postulate. 2 little segments add up to the big one. Then I plug in their values, 6 and negative x plus 1. I don't know this one yet, so I just leave it blank. I plug them in by substitution. Then I subtract 6, and I get that CD is negative x minus 5. Great, so I write that down. I'm going to do the same thing over here. AC minus BC gets me AB. So I'm going to write that. AC is AB plus BC. I plug in their values. I subtract BC, and I get x plus 10 for AB. Whoops, sorry. So I write that down. That's the first 2 steps to figure out what these 2 are. How do we feel about finding those first 2 segments? Okay. Again, the idea is I take this guy, and I subtract this amount, and I get what's left over. I take this guy, and I subtract this amount, and I get what's left over. The setup was to write the segments, right? Those 2 add up to this guy, and then plug in their stuff and solve. After I know what these 3 are, I'm going to add them all up, and I'm going to set them equal to this guy, because they are. So I do that. The purple, the green, and the blue all add up to the pink. So I write that by segment addition postulate. Then by subs, I plug in what they are. And then I solve for x, and it's 5. After I get that, I plug it in. I found out earlier AB is this, right? And so I'm going to plug in 5 here and get that it's 15. So I plug in 5. AB is this. Plug in 5 by substitution, and I get 15. It's one of the longer proofs, but if you break it down by ideas, it's not so bad. The first idea was to figure out what this segment is. It's this guy minus 6. It's negative x minus 5. Then I need to figure out this guy. So I took this guy, minus 6, and got him. After I know what all 3 are, I add them up and set them equal to this guy. Solve for x, and then plug it back in to find out what AB is. It's 15. We feel okay about that. Ellie, yes, you want to take a picture? That's what I would encourage you to do. Don't try to copy everything down today. I also have a packet that's already been filled out, right, that I can give you to look at if you need to. It's right here. So I can let you look at stuff. But I would encourage you to just take a picture at the end. Or go online and watch the review from yesterday. It was funny. First hour was boring. The last 2 hours were great. Yeah. Like this. Here. I would highly encourage you to watch it. Or come in today. It's pretty funny. I tried watching it last night before I went to bed, but then I actually accidentally went to bed while watching it. Hate when that happens. I did. I got a lot of sleep last night. I went to bed at like 9 and woke up at 6. I hate when that happens. All right, moving on. Same idea for the next two. Practice on those. Number 4, buckle up. It's a lot, but not if you know what it means. First, we label our points. Then we find out what A and B are. And then we plug those into Pfag. That's the idea. Okay, that's all it is. Label your points. Find out A and B. Plug them into Pfag. Now let me explain what's going on here. First off, coordinate plane. Meow, right? So x1, y1 is this coordinate. And this would be x2, y1. This coordinate up here would be x1, y2. So that's how I label my coordinates. A is the vertical part. Well, how tall is A? Well, it's going to be whatever this number is minus this number. That's how long that distance is, right? If this guy's 10 and that's 2, how far are they apart? 8. So whatever they are, I subtract them and I find out the distance, right? So that's what A would be. It would be y2 minus y1. B is between x2 and x1. So if that was 10 and that's 2, how much distance is between them? 8. And you did that by subtraction. So algebraically speaking, it's whatever these two guys are subtracted. That's how long B is going to be. So now we know what A and B are. I wrote that down. And I told you what they mean. Subtraction is distance. Y is vertical. So that's the vertical distance, right? And it is. It's how far we travel from here to here vertically. How far do we travel from here to here horizontally? Well, it's that much. That's B, the horizontal distance. So now that I know how far they are apart horizontally and vertically, I can plug those into the Pythagorean theorem. I know A is y2 minus y1 and B is x2 minus x1, so I plug them in here. Then I rooted and I got my distance formula. That's where it comes from. That's why we have the distance formula being this mumbo jumbo. It says take the vertical distance and square it, take the horizontal distance and square it, add them up and root them, and that's going to get you the overall distance, right? This distance is the diagonal. We're moving both vertically and horizontally at the same time, and that's hard to calculate how long it is, so we break it down into easier distances, the vertical part and the horizontal part, and then plug it into Pfag. This is beginning of the year stuff, so it's a long time ago, so I'm taking my time on it a little. Hopefully it's ringing a bell, and if it's not, come to the review session and we can talk about learning it for the first time if you didn't learn it way back when. Okay? Yeah.
How many pages final?
I don't know, I haven't made it yet, but it's going to be between 20 and 30 questions. I would imagine closer to 20.
Can you move it down a little bit?
I can zoom out, yes. Yep, please. Deuces. Who's on your shirt? Rock on. Did you go see him? No. You've never what? Well, Chicago's kind of a pretty big. Okay. 2020 math class concert tour next semester. Oh, we're taking a field trip to Chicago because the math museum. Go see a concert. Well, we had extra time. Next one. Two things they want for this problem is the distance between those 2 points. So we're going to use distance formula. And they want us to break it up into this ratio, 1 to 1. Well, 1 to 1 ratio just means it's the same on each side, right? 1 on this side, 1 on that side. You could also write it as 2 to 2, right? As long as it's the same on both sides, that's the ratio 1 to 1. Okay? So really what we're doing is we're breaking it in half, right? If it's the same distance on both sides, we're breaking it in half. That's what that means. So in order to break it in half, we need to find the midpoint. Midpoint formula is average of the x's, average of the y's. When we average stuff, we add them up and divide by the number of pieces. Here we have 2 total pieces, 1 and 1. So there's my midpoint formula. 1 of each, divide by 2. Bless you. 1 of each, divide by 2. I plug in my coordinates here. Remember, x2 and y2 come first. That's important. x2 and y2 come first. We plug in our stuff. We add them up, divide by 2. We find the midpoint. It's 3, negative 2, which is halfway between a and b. Okay? Then to find the distance. Yeah, we could use distance formula and plug all those numbers in. But remember, what does this stand for? It stands for horizontal distance. Well, you could calculate it doing math, or you could just say, look, the horizontal distance is 4. Right? If you calculate it, you get this, which ends up squaring to be 16, right? Or you could just say, look, I can count it. So why not just write it? Put it in pfag, right? You could calculate the vertical distance using the coordinates, y2 and y1. Or you could just count it, right? It's right there. And plug it in. Either way, you get the same thing, 4 squared and 10 squared. Negatives don't matter because when you square them, they go away, right? And you get root 116 either way. How do we feel about distance formula being pfag? That's what I would do. I just do pfag to solve that. Way easier. Don't mess up this math. Midpoint, average the x's, average the y's. Number 6 has a different ratio. It actually gives you a fraction, 3/8. So it wants to find the point that's 3/8 of the way between a and b. A point like this, not quite halfway, right? Do you have a question?
Can I see that little piece of paper?
This one, you mean?
Has it done? Yeah.
Yeah.
I want to see that.
6. Is 6 done? Yeah, 6 is done. Here you go. So, we want to find a point that's 3/8 of the way between a and b. So instead of using 1-to-1 ratio, we're going to use a 3-to-5 ratio. Why? Because 3/8, 8 total pieces, 3 of those 8s is on one side, and 5/8 is on the other side. So a 3-to-5 ratio. Clicking? All right. So instead of using 1 and 1 here like we did last time, you didn't see that because I didn't write it. And I didn't write 1 and 1 here for our 1-to-1 ratio because 1 times x2 is just x2, right? It's like an invisible 1 in front of the x. But here, we do have the right numbers because we're using a different ratio. We're using 3-to-5. So we get 3 x2s. x2 comes first, and then 5 x1s. Same thing for our y's. Again, x2 and y2 come first. The reason for that is because we're going from a to b, not b to a. If we go from a to b 3/8 of the way, we end up here. But if we start on b and walk towards a, 3/8 is right there. See how it gets us a different point? Right? So you want to make sure you're starting at a. And the way we do that is we write x2 first. Okay? And that's kind of backwards, but it is. I can explain later. 3 and 5 for 8 total pieces. So it's still midpoint, right? Midpoint formula. It's just not finding the midpoint. It's finding 3/8 of the way. 3 pieces and 5 pieces for 8 pieces total. Okay? When I plug in my coordinates, I get negative 32 and negative 8. I divide those by 8 and I get negative 4 and negative 1, which is a point that is 3/8 of the way between a and b. Starting on a, walking towards b. If I started on b and walked towards a, 3/8 would be this way. The beginning is the most difficult part. It's from a long time ago, and it's stuff you guys probably didn't really learn the first time because you thought you could BS this class way back then, right? And you learned very quickly you could not. Do you have questions on this? I would like to help. Yes?
So the like x2 would be like the first side of the ratio, x1 would be the second side. So
Mm-hmm.
it's like 2 is 3 and 1 is 5.
Yep. Mm-hmm. Yep. 3 goes with the first part, 5 goes with the second part. Mm-hmm. Mm-hmm. In that order. We're still averaging, right? We have 3 x2s and 5 x1s for a total of 8. So we're still averaging, right? Any other questions? Okay. 7. The ratio is 1-to-1, so what formula are we going to use? Midpoint formula, because it's 1 on each side, halfway in between, right? Average of the x's, average of the y's, divide by 2. This one, The fraction they give us is 2/7. So what ratio will we use? People that weren't here yesterday. What ratio will we use if they want 2/7 of the way? 2/5, right? 2 on one side, 5 on the other. And you'll set it up like that. 7 pieces total. x2 first, x1 second. 2/5. Do the same thing for your y's. Distance formula is Pythag. Count the squares. Square them, add them, root them.
5x1.
Yes, it is. Again, any questions on this stuff? Guaranteed there'll be a question like this in the final. Guaranteed. I might not make you do distance formula with it, but I will have you find like 2/7 of the way between 2 points. Okay. Next one. A lot of stuff going on here. This is really confusing for you guys when you looked at it before, but it doesn't have to be that bad. Normally, midpoint takes the 2 outer points and plugs them into the formula, right, for x2 and x1 and y2 and y1, and pops out your middle, right? Normally that's what happens. And the formula looks like this, right? And it pops out this guy. Well, they're saying, I'm going to give you that guy already, and I'm going to give you one of the endpoints. But the other one we're looking for. So we know this, we know that, but we don't know the other one, right? So normally we plug in our 2 endpoints here and here, but we're only going to be able to plug in one of them. So here's what I did. I plugged in my midpoint, which they gave me, 1, 5 halves for the midpoint. Don't plug it in here. It's over here. That's what the midpoint is. They said so. Then I took the endpoint and plugged in the first endpoint, because that's the one I know. So I plugged in for x1 and y1. And x2 and y2 are going to be that mystery endpoint I'm looking for. How do you feel about the setup so far? Yes?
Can you explain it again?
Mm-hmm. So midpoint formula normally takes your 2 endpoints, right? And plugs them in here. And then we do the stuff and we get our midpoint, right? Well, for this one, they've already given us the midpoint, 1, 5 halves. And they gave us one of the endpoints, so I'm going to plug it in for the first endpoint, x1 and y1. The other endpoint I'm looking for, so I leave those as variables, and I'm going to solve for those, okay? How do you feel about the setup? Mm-hmm. Good? Okay. So normally we do our math here, right, after we plug in our endpoints, and it pops out the coordinate here, right? So this part should equal that part. So I'm going to write that. x2 plus a negative 3, well, I write that as x2 minus 3. Over 2 should equal 1, right? Those go together. Now I solve by timesing by 2, I get 2, and then adding 3 to get rid of that, I get 5. How do you feel about that first part? Timesing by 2 to get rid of divides by 2, and then adding 3. If we times by 2 and then add 3, we get 2 and then 5. Doing okay? Carver, you with me? Okay. So we're good up to here, right? The setup? So now to get x on its own, I have to get rid of divides by 2. So I'm going to times by 2. And I have to get rid of a minus 3, right? So I'm going to add 3. So first I times by 2. What does 1 become when I times it by 2? Try again. Times by 2. 2. Now add 3. 5. And now x is on its own, right? Better? Okay, okay. The other side. y2 plus a negative 2. Well, that's just y2 minus 2. So I write that equal to this. They equal each other. Now, when I multiply by 2 to get rid of the division here, I'm multiplying 5 halves by 2. What's 5 halves times 2? Well, it's 2 divided by 2, which is 1, times 5, which is 5. So I get 5 equals y2 minus 2. Gets rid of both of those. And then I add 2 and I get 7. So 5, 7 is the coordinate. Marissa, how do you feel about that last part?
Good.
Okay. Carver? All right. Again, we times by 2 to get rid of this, and it magically gets rid of that 2 there. Because 2 divided by 2 is 1, times 5 is 5. And then we add 2 to get y2 on its own. Doing okay, Jenna? Okay. For real? Okay. Yes.
So you multiply the denominator by the y1, and then so you get 5
Yeah, so we're here, right? And we times by 2 to get rid of division. When I do that, I do 5 halves divided, or 5 halves times 2, right? What is 5 halves times 2? It's 5. 2 divided by 2 is 1, times 5 is 5. So I get this, and then I add 2. Better? Okay. Thank you for asking. I appreciate all the questions. All right, easier stuff now. Number 12, name the angle. Angle MAP, angle PAM. Either way works. Remember, A has to be in the middle because it's the vertex. We're on page 10 of your hymnal, question 12. We can also call it by its number. You don't see that a whole lot, right? Angle 5 is what we can call that. Doesn't mean it's 5 degrees. And then we can call it angle A. Again, calling it by its vertex. I don't like that because if there was another ray sticking out of here, then you wouldn't know which angle was angle A. It could be the top, it could be the bottom, right? Or it could be the whole thing. So not as good as labeling it with all 3. But it's still another way to name it. Then it says name the rays. Hi, Ray. This is ray AM, going from A to M. Order matters, going from A to P. Okay? How do you feel about naming this stuff? I would hope pretty good. We have to do it pretty much all the time when we talk about problems, right? It's like step 1 is to figure out what they're talking about, right? 13, definitions. Oh boy. You know what these means. You know what these means. You know what these mean. Acute is between 0 and 90, right? Can it be 0 or 90? No, it can't, because if it was 90, it'd be a right angle, right? So I said angle A is acute if it's between 0 and 90, doesn't include 0 and 90. It's like saying pick a number between 1 and 10. You can't pick 1, you can't pick 10. This is saying it's between a number, 0 and 90, but you can't be 0, you can't be 90. If it had a line underneath here, less than or equal to, then it could be 90, but we don't want that, right? Because if it was 90, it'd be a right angle. So we have between 0 and 90, non-inclusive, acute. Exactly 90 is a right angle. Between 90 and 180, non-inclusive, is obtuse. Exactly 180 is straight. Between 180 and 360, that's a lot of territory, right? Between 180 and 360 is reflex. That's where you hyperextend your elbow. Yep, just stop. If it's exactly 360, it's a revolution, right? The Bernie Sanders. A and B. If A adds with another angle to make 90, then they must be complementary. If A adds with another angle to make 180, they must be supplementary. How do you feel about those? Do you have to write it just like this? No, you can use your own words. But don't say an acute angle is between 0 and 90. Because that implies it could be 0 or 90, right? Say it's between 0 and 90, but can't be 0 and 90. Yeah.
I'm confused on like the very first step where it's like the 0 and then like, what is that?
So this is saying 0 less than measure of angle A less than 90. But don't read it like that. Angle A is between 0 and 90. Does that make sense? An angle between 0 and 90 is acute. Can't be 0, can't be 90.
Is that revolution or reflex?
Revolution. Yep. If you need to take a picture, here it is. I think I can zoom in and get all of these. Yeah. Again, I have them. Well, actually, I don't think I have them written down anywhere else. I think I just have them written down here. I might have written them down in the other packet. I'm not sure. Page 10. I don't think I have them written down in this one. No, I do not. But I do in the other, I think. Cool. Yes?
What is it? 180 greater than, what is that?
180 less than measure of angle A, less than 360. So it's 180, but measure of angle A is between 180 and 360. That's how you should read that.
So reflex angle is between 180 and 360.
Right, it's the hyperextension one, right?
Is that going to be the exam?
Is it in the final review guide? Then it has a good chance of being on there. Would I ask for all of them? Probably not because of time, but will I ask for some? Probably. And if I don't ask for them, you're still going to need to know. Like, you need to know what supplementary means. We're going to use that all the time. You need to know what a right angle means. We're going to use that all the time. Straight angle for linear pair, we're going to use that all the time, right? Reflex angle, we're going to use that coming up. So, yeah. Will it be a direct question? Maybe not, but you're definitely going to have to know it. And it might even be a direct question, right? I haven't made the final yet. Try to do that tonight/tomorrow. I'm gonna be here till 9, so. Next page. Oh God, don't look at that one. I need my review packet back. Sorry.
It's fine.
I wrote this one down incorrectly. There's a minor change, 2 minor changes you have to make. So, look at the diagram. First of all, that arc right there isn't referring to CAF. So we need to make an arc that does refer to CAF. So make a green arc right there. That's what should be 95. And then lastly, BAF does not equal 165. It equals 135. My bad. I forgot to move the arc and it screwed up everything. This is what happens when I take old problems and make them new ones. Okay? So we want to prove that BAF, that's this big angle right here, is 135, given that CAF is 95. So first I write given CAF is 95. Then I'm going to say that this angle, and this angle all add up to CAF. I do that by angle addition postulate, right? 1, 2, and 3 add up to CAF. That's angle addition postulate. All the little angles add up to the big angle. Then I plug in their values by substitution. So I say 35 plus 2x plus 40 equals CAF, which we said was 90, right? They gave us that. 95. That's substitution. Bless you. And then I solved for x and got 10. So far, so good. These 3 angles add up to the bigger angle. 35 plus 2x plus 40 by substitution equals 195. I'm sorry, not 195, 95. Numbers are hard. Then I'm going to write that these 4 angles add up to the biggest angle by angle addition postulate. Then I'm going to plug in their numbers. 4x plus 35 plus 2x plus 40 all equals this big angle. I don't know what that big angle is yet, so I didn't write it in. That's by subs. Then I plug in 10 by substitution because I found x was 10 earlier. And then I do math and find out that BAF is, in fact, 135, like I was supposed to prove. So we have 2 sections here. These all add up to this guy. Find x. These all add up to this guy. Find BAF. It's 135. You're going to need angle addition postulate and substitution. Is that, boys? Questions? Yes. Is that getting everything? I don't know who was here later last night, me or Jeff. God bless that man. Probably. Oh, gotcha. Jeff serves and protects this school. It's wonderful. We have really great people working here. We really do. I know you guys have gone to this high school and you've been to this district a long time, so you get the I hate my school type of thing, and I get it. I'm not Mr. School Spirit either. But, like, this is a really good collection of teachers and staff. It's not perfect, but it's pretty good. Yeah, sure. Next one. Oh, God, it's a star. Shine bright, shine far, don't be shy, be a star. Where you live, where you are, be a star. Anybody? Lindsay Lohan, first Disney movie she was ever in. It's called Life Size, starring Tyra Banks. She was a doll that got brought to life. Yeah, you know what I'm talking about. Right? Be a star. And then Lindsay Lohan didn't. She get help, Lindsay. Not making fun of you. Get help. Mental illness is not a joke. All right, this star has 10 sides, so we call it a decagon because, of course, December is the 10th month of the year. So dec, like December, is 10.
That's a way to remember.
Yeah, except December is the 12th month of the year. It used to be the 10th because the Romans, right? They had it make sense. And then we're like, we'd rather January be the first month of the year. Why do we call February February? I don't know. But I know why we called December December because it was originally the 10th month, right? Which means November was the 9th month. Novembre, right? Makes sense. October, 8th month. September, 7th month, right? It makes sense, doesn't it? They changed the 6th month to August because Augustus Caesar was a big deal, right? And then they changed the 5th month to July because Julius Caesar was a big deal as well. Doubt it.
No, my uncle said I am, so I guess I am.
Yeah, my uncle used to say I was related to Edgar Allan Poe. He hated our family, and so he dropped the R from his last name. It used to be Poer, P-O-E-R, but it turns out it's not true. Yeah, I know, right? It makes sense. I have no soul. It's concave because at least one of the internal angles, we have lots of internal angles, right? The inside angles, at least one of them, 5 of them, are all greater than 180, meaning the reflex angles, hyperextension, Marissa, yep, don't do it. So all those are greater than 180, the reflex angles, they hyperextend, so that's concave. Another way to tell if something's concave, if you extend one of the lines and it goes into the object, it concave, because it caves in. Yeah, it's like a cave, but sometimes it's hard to tell. Like sometimes things can look concave, but they actually aren't. But the best way to tell is, do I have an angle on the inside that's greater than 180? Do I have lines that go through it? Then yeah, it's concave. Then we're going to calculate the perimeter, so we need to find the length of each segment. So how do I find BC's length? Well, I count it because it's perfectly horizontal. It's 8. Hey, we like those. How do we find something like JK? Oh, God. Here's how we do it. We don't count it. We break it into a triangle and we do distance formula, right? PFAC. It's 4 by 3, so 4 squared and 3 squared makes 25 when you add them up, and then when we root them, we get 5. Same thing here. That's 4 by 3, and that's 4 by 3, so we have 3 5s. They're all congruent, so I put a little tick mark by them because it says mark congruent segments. Mark congruent segments.
You gave me that with yesterday.
So it's 4 by 3, and we mark all the 5s. Calvin. So when I made my triangle for this segment, it was 4 and 3. 4 squared is 16. 3 squared is 9. If I add 16 and 9, I get 25, and then I root it, I get 5. It's Pythagorean theorem. A squared plus B squared rooted. Okay?
So you do 4 squared, 16, 3 squared, 9.
Add them up.
Add them.
Square them, add them, root them. Great question. Notice this one's 4 and 2, which doesn't come out nicely. It's 16 and 4 when you square them. That makes 20. When we root it, we get root 20. Same thing here. Here it's 5 and 3, so that's going to add up to 34 when you square and add them. Doesn't come out nicely, so root 34. Here it's 2 and 7, so that's 49 and 4. That makes 53 rooted, right? And that's root 53 as well, because they're both 2 and 7s. So I mark them because they're congruent. With 3 marks here, here, and here to say, hey, they're all the same, right? As opposed to the single marks here, here, and here. And the 2 marks there. Now you add them all up. So look down here. I had 5, 5, 8, and 5. That adds up to 23. I had 2 root 20, so I wrote 2 root 20. I had 3 root 53s. So I wrote 3 root 53. And I had 1 root 34 all alone, just like you will be for the rest of your lives. Mm-hmm. Mark's never alone. He's omnipotent. He sees you when you're sleeping. All right. That was 15.
Wait, is the one next to it, like, the one next to 40C, is that
Root 53. CD was root 53 in length. Turning the page. Where's the other packet? You can have it. Here. Take it. We're almost out of time. Did we get through the whole packet? Oh my God, we didn't. Right? First of all, concave or convex? Concave. 2 angles are greater than 180. Also, it definitely caves in. This is an octagon because it has 8 sides. Imagine being someone that's like told to make like a UFC fighting ring, and they're like, make an octagon, and you make this, right? And fight. Oh my God, where is he? He's over here. He's hiding. We gotta go find him, right? They said make an octagon. Creative freedom. Hexagon, 6 sides. Is it concave? You betcha. It's got at least 1 internal angle that's greater than 180. Also, if you were to extend this line, it would go through, right? Is it concave? You betcha. 2 angles internally are greater than 180. You would extend this line, it would go through. This is a dodecagon because it's 10 sides plus 2 more. Do means dos, as in 2, and dec means 10, is like December, the 10th month of the year. So it's a dodec, 12 sides. An example of a convex polygon, since I didn't give you one, would be like a rectangle. See how all the internal angles are less than 180? See how if we extended all the lines, none of them would go through the middle? Yeah, so it's convex. That's concave, though. Easy proof, here we go. Given that negative 3x minus 7 equals 14, prove that x is negative 7. We're on number 19, page 16 of your hymnal. We're going to add 7 by addition property. Then we're going to divide by negative 3 by division property. And we're going to get that x is negative 7, and we're done. We do addition property to move the 7, and we do division property to divide by the negative 3, right? Yay, easy proof. Number 20, for fun, for funsies. What two properties will we use to solve this one? If you were here yesterday, don't answer. We'd use addition, right? And then multiplication to get rid of the divides by 2. So do that with the proof, and you're good. You'll find x is negative 32. 21, it says A, B, and C are collinear. I swear to God, what does collinear mean? On the same line. In that order. Don't write it A, C, B just for fun, okay? Like, we're all about creative expression in here, but it won't work that way. You have to do it in order. AB is this, BC is that. They say AC is 6. That's the whole thing. I know the two segments make up the big one, so I wrote that by segment addition postulate. AB plus BC equals AC. Thank you. Then after this, I would plug in their values by substitution, right? And then I would solve for x. X would be a number, and I'd plug it in to find what BC is, and I would get 2. When I plug stuff in, remember, it's called substitution, right? So I think here I would get negative 2 for x. After all is said and done, I'd plug that in, and I'd get 2 for BC, okay? And again, when we plug stuff in, we call that substitution. Feeling decent? Okay. Yes?
Are we gonna go over all of it in the next 3 hours?
Tonight? Yeah, we will. Every problem you want to do, however long it takes. Okay. Next one. 23, page 17. I just started it, and then I explained the rest. This one, the setup, is all I gave you. The rest I'll explain out loud. So the setup says D is in the interior of angle ABC. So I drew ABC, and I put D in the interior. So far, so good. ABC is 165, so that's the whole thing. ABD is this angle. They said it's x over 3 plus 45, so I wrote that in. Then they said this was 3x plus 20, so I wrote that in. So that's what they gave us. That's the given. Boop. They want us to prove that ABD, the red angle, is 55. So here's what I do. This angle plus this angle equals the whole thing. That's angle addition postulate, right? Then I plug in their values by substitution, and I solve for x. Turns out x is 30. Then I substitute 30 for x, divide by 3, add 45, and I get 55, which proves that ABD is 55. So first off, angle addition postulate. They all add up to the big one. Then I substitute their values, so I have an equation. Then I solve for x. Then I plug it back in with substitution, and it's 55. Again, this angle plus this angle equals the big angle. That's angle addition postulate. That means x over 3 plus 45 plus 3x plus 20 equals 165 by substitution. I solve for x, plug x back in, and I get 55. Yes?
So the diagram is the given.
That's the given, and then I'd write the rest of the proof, which I have said out loud.
So like you get 45, you don't write.
If you're solving this without writing the diagram, God bless you, child. God bless you. Write the given, because 1, it's 3 points, and 2, it kind of helps you set up the problem, right? Okay. This one really messed up everybody on the quiz. Let me explain it, okay? Ignore this. First off, they gave us JK and LM are the same, so I wrote them in the same color. And then I marked the diagram. Then they said we want to prove something about JL and KM. Well, we didn't get any information about JL or KM, so we have to go find it in the diagram. Notice that JL is this red part, and Km is this orange part. Well, JL is just JK plus KL, right? Those two little guys put together. So I wrote that down. And KM, the orange part, is just LM plus KL. So I wrote that down. Both are by segment addition postulate. Two segments make up the big guy, right? Then I rewrote JL equals JK plus KL. I rewrote that as JL equals LM plus KL because they're switch outable, right? Notice now that these two are both the same. So if that equals that and that equals that, then they equal each other by substitution. Then I flipped them around the right way because they wanted red first and orange second, and I did that by symmetry. That's by symmetry property, where you can flip both sides of an equation and you're good. So we got here, these two equal the same thing, so they equal each other. And then I flipped them to get them in the right order by symmetry. Yes?
What, you know what chapter those rules are from?
These rules, I gave you a thing called the Proofs Toolbox that I handed out to you guys. It should be on Google Classroom if you can't find it, okay? Next one. Oh my God, look at all that garbage. Color code, right? And then write it down here, and then it's not so bad, right? This is what we're given, okay? They want us to prove that blue and orange go together. Aww. So here's what we're gonna do. See, there's blue and there's orange. We need to get them together. Oh no, you don't see it. Blue and orange need to be together. They must. So how do we get them in the same room? Well, orange knows green, and green knows purple, and purple knows blue. Smell I'm stepping in here? If there's a will, there's a way. So orange is green, and we can switch out green for purple, right? And then we're gonna switch out purple for blue. And now they're together. Aww. So here's what I did. I said orange is purple because purple and green are the same thing. Then I said orange is blue because purple and blue are the same thing. Both were by substitution. Then I flipped them in the right order, so it would be blue first and orange second. By substitution, and then symmetry to flip them. Done. If you know what you're doing, this can be really easy, and if you don't know what you're doing, it feels impossible. So if you don't know what you're doing, come talk to me, and I guarantee I can teach you what I promise. I promise. I promise. Chance, how do you feel?
Great.
That's what I'm talking about.
That scared me. Does that say by?
Symmetry. Down
No,
here.
the one above it.
By subs.
Okay.
It does say by rules, doesn't it? It looks like rules. Rules. And there's more. I would encourage you to watch the review. First hour is boring. The first review, the first one I ever do. First hour is boring. Second hour is hilarious. Last 2 hours are hilarious. The second review and the third review, I go through it super fast like this because it was Nelly and Chance here, and they were flying through stuff because they really know their crap. Second review that I did was a little bit slower, but I didn't write stuff down. I just went through this slowly, I think. Or no, I did write it down. I have 2 packets. But it wasn't nearly as funny. Mostly because Taylor wasn't there. Portfolios were due today, but I will accept them at the beginning of class tomorrow. You better have them printed before you get to class. Thank you. I will not accept them tomorrow if they're not printed. Rad. Rad. That's cool. Appreciate it. See you later. I love you all. Let me know what I can do to make your life less stressful.